All right, this starts section 3 of chapter 2. We've already looked at what earthquakes are, what causes earthquakes, what seismic waves are, how we measure earthquakes, and locating epicenters. Now we're actually going to look at probably what is more pertinent to most of you is the hazards and safeties and how to deal with an earthquake if you find yourself in the presence of one. So, how do earthquakes cause damage? Well, if I'm going to move the ground underneath you very violently, then everything that's sitting on that ground is probably going to move violently as well. Those S&P waves are going to travel through medium. They do not want to go through the air very well, so they will go through whatever's on the ground, which could be your car, your buildings, bridges, all that other infrastructure. So earthquakes are going to cause damage to that infrastructure. They're also going to cause damage to landforms. They're going to cause landslides and avalanches, as well as if they do happen in the ocean, there is a big concern for tsunamis, which we'll get to at the end of this video. So first thing you need to realize is your local soil conditions. Depending on where you are, your soil is going to be made up of different material. And these S&P waves, these surface waves, are going to vibrate that material differently depending on what it is. If you have a loose material, so if you're in like filled in land or something like that, which most of Pennsylvania is because we're a bunch of mines at least, you're going to get more violently shaking. Luckily for us, we're not really located near fault lines, so we don't experience earthquakes all that often. However, there is every now and then reported cases of them. So loose soil is going to shake more violently than hard rock and more dense soil. You're also going to get something called liquefaction happening. This is what's going to trigger your landslides, but basically if your ground has a lot of moisture in it, if you're in a place that rains a lot like we are, when the ground moves, all that dirt is going to release the moisture and it's going to liquefy into mud. Once it becomes mud, it's very loose and doesn't hold things together, and that's what causes your landslides. If you lack that moisture, then you're not really going to get mud, and your landslides aren't going to be as dangerous. However, it can shake free loose rocks and dirt and stuff like that and have them slide down. The next concern that you have are called aftershocks. Aftershocks are going to be earthquakes that occur after the initial earthquake. So as your two plates are moving and they're experiencing this friction, they're getting hung up on it. When it breaks past that force of friction and allows it to move, it might get caught up again very briefly before it moves again. These are what we refer to as aftershocks. So if you look at our seismograph down here, you do get the main earthquake, which was the big one. Had all that energy in it. It lost all that energy, and then it got caught again while it was over here. So now as time goes on, the plate gets caught again, but it doesn't get caught as hard as it was on that one. The friction gives way, and you get another earthquake to release the energy that was stored up there. These aftershocks could happen hours, days, or months after the initial earthquake. So there is a big concern that just because the ground stops shaking, that it is now safe. You do have to be aware of aftershocks. Last part of this video is going to talk about tsunamis, and this is what's going to happen when the earthquake's epicenter is in the ocean. Basically, I'm moving a whole bunch of crust very quickly. If it's underwater, all the space that I moved into is going to displace all that water. That's a lot of water being moved very quickly as well, and it's going to turn into what we call tsunamis, or these great waves. Let's get my microphone information out of there. That's great. There we go. Sorry about that. These giant waves are going to be perpetuated by the energy of this water displacement. As you go out into open ocean, these actual waves are very small because they are dealing with columns of water. So you can think of how deep it is out in the middle of the ocean. There's a lot of space for that energy to be. As it gets to the shoreline, the energy is going to rise up out of the water into that wave because the energy can't be going down. It's going to be very shallow towards the shoreline. So same column of water needs to have the same amount of energy, so it's going to get taller, and that's going to cause your massive wave. And those waves have their own damaging effects, as you can probably imagine, uh, not only of the force behind it, but also the destruction and flooding and problems after the wave occurs as well.